Hello everyone, I hope you all are doing well. This video was inspired by my sensei Yuri Artoik, so a big shout out to him. In this video, what we are going to make today is this really cool wave effect from the website known as Taotajima. And this is really easy to make. I know you don't believe me, but this is really easy to make. And there is also this scaling effect as well as this magnet effect. And we're going to make all of these, okay, and it's going to be really simple, trust me. So let's get started before I start yapping too much. This is the part 2 of the video mixing WebGL and HTML. So if you haven't watched that video, go watch it and come back. So let's check what we have in the JavaScript. So basically this is what we made at the end of the part 1 video, and now in this video we're going to be making this wave and this magnet and the scaling effect, right? So the first thing we want to do is I have to set up the uniforms. Okay, I haven't set up any uniforms because this is exactly what we did in the previous project. So what all uniforms do I need? I need the mouse coordinates, then I need the value in which I want to check if this is hovering or not, and then I need the time variable to make this wave go on forever. So let's start doing that. I'm going to create a new uMouse, which is going to be a vector2 variable, and then I need a u. Wow, u is called glitching. I need a uEnter, and yeah, that's it for now. We have the uMouse, which is a vector2, and uEnter, which is a float value. So normally, if we want to add a mouse move event in threejs, we use the raycaster, right? But we don't need raycaster in this case because the WebGL image is exactly on top of the HTML image. So if I am adding the mouse event listener to this HTML image, it should give me the exact same values as the one which we get from using raycaster, right? So I'll show you what I mean by that. So I'm going to add an event listener on this image by saying image.add event listener and a mouse move event. I'm just going to pass an event. Cool. Now I'm going to get the x value by saying e dot. I'm not going to use the client x, but the offset x divided by width. Likewise, for the height, I'm going to divide it by e dot offset y and height. That's it. Now I just have to animate this value. So we need the lerp to make it look much cooler. So I'm accessing this image material and I'm updating the value of uMouse by saying x. Okay, if you don't know, if you are thinking why didn't I give it like this, because if the variable name and the value we are gonna pass is same in name, so we can just do it like this. So since my x is same as this x and my y is same as this y, then I just have to do it like this, and this is a JavaScript thing, and I think we all know that. Okay, now we have the mouse move uniform, and the next part is to check if we are hovering or not. So I need to add a mouse move, mouse enter and mouse leave event. So let's do that. Add event listener, mouse enter, and then I'm going to say gsap.to exactly. So I'm animating the value, which is the uEnter, from 0 to 1 in that time of 1 duration. Cool. And I'm going to say the same thing for mouse leave, but I'm just going to animate it back to 0. Cool, right? Now it's as easy as that to set up the uniforms. Now it's all in the Vertex shader. Why did we use Vertex shader this time instead of fragment shader? You must be wondering that, right? So if you want to animate the vertices, for example, if you want to make a wave or something like that, which includes manipulating the size the width, we are going to use the vertex shader. So in this case, we are going to use the vertex shader, and I'm just going to import all the uniforms, which is vec2 uMouse, then the uniform float u enter. Cool. Now, in the previous video, I explained how to make a circle with that follows our mouse around. So I'm just going to use the same formula and also explain what happens here. So let's say circle, which is equal to, we're going to use the smooth step function, and the first parameter is going to be the radius of the circle. The second parameter is going to be how smooth the edge of the circle is going to be, and the third parameter, we are going to calculate the distance between the VUV or the UVs and the mouse. Okay, cool. Now, I can't output this because I'm in the fragment shader. You must be wondering that. How are we going to see if this is working properly? So I want to pass the circle value to this fragment shader. So normally, if you want to pass a value like that, we have the variants, right? So I'm just going to create another variant called float v circle, and v circle will be equal to this circle, and I come here, import it here, copy, paste, v circle 0. Oh, holy shit. I think we forgot something. You must be wondering why. Look, if I am moving my mouse in the y direction, it's going in the opposite direction. So, you know that the y direction in threejs is flipped. So, if you want to make it work, you just have to invert it. Okay, I think something is wrong. Offset dot width. I didn't check this part. This is a VUV. My bad. Okay, now we have the mouse which follows. We have the circle which follows our mouse around, and I think the duration is too much. Let's say 0.5 works. Yeah, now we have this. Cool, right? But this is not a circle, this is an oval. The x direction of this mouse is stretched. So I want this to be a perfect circle because it is a perfect circle in this one. How do you know? If you look closely, you can see the wave and it's almost a perfect circle. So I'm going to correct the aspect ratio of the circle. So in order for that to work, I need the aspect ratio of this width and height of the image. So which is basically aspect. I'm going to create a vector2 variable which contains the width and the height of this plane, this get bounding client rect width and height. And I'm going to come here in the vertex shader and import it by saying vec2 aspect. So let's create a temporary variable for the new aspect corrected mouse. So I'm going to say aspected, or what, or let's say aspect corrected mouse, which is equal to vec2. I'm just going to pass down mouse x and come on mouse y. Okay, now if you look closely, there is something wrong, which is dimension mismatch. Sorry, this is a vector2. Yeah, oops, yeah. And then the x part is stretched, right? I don't have to change the y part because it is perfect. Now to make the aspect ratio correct in the y direction, I'm going to multiply it with aspect dot x divided by aspect dot y. Let's see what we have. Okay, instead of this normal u mouse, I am going to use aspect corrected mouse. Okay, we don't have anything. Why? Aspect dot x, aspect dot y. This should work. Okay, so what's the problem here is I'm changing the aspect ratio of this mouse, that's correct, but I'm not fixing the aspect ratio of this VUV. Okay, so what I mean by that is just have to repeat the same thing for the UVs. So instead of U mouse, I'm going to say VUV or UV, and instead of using the VUVs here, I'm going to pass aspect corrected VUV. There you have it, the perfect circle, and it's so satisfying to see this perfect circle. Okay, that's done. The first part is done. The second part is to make this wave. Okay, and how are we going to make a wave that starts from the center? It goes like the ripples and it follows our mouse around. The center of this wave changes. So it's really simple. So what I'm going to do is, if you look closely, the wave is in the z direction, only in the z direction. So I'm going to add a wave in the z direction. So let's say position dot z plus equal to, it's always a sine wave. You know, these kinds of simple waves are sine, otherwise it would be a noise function. So let's say I'm going to pass the time variable and end it here. If I want to start a wave that's from the center, I can use the same concept I used to make a circle, isn't it? So I just have to copy this distance and pass it here, plus, okay, can we see something? I can see the plane moving a bit, so I'm just going to multiply it, say 10. Okay, I can see it moving, but it's, the frequency is too low. So let's say I'm multiplying it with 10. Okay, something is happening. The wave is following my mouse around, but it's applying to the whole plane. So let's see what this looks like. Okay, I'm going to create a variable known as float wave, which is equal to this guy. I'm going to come here and say wave, and also I'm just going to output the wave to see how it looks like. Yeah, okay, there you have it. You have the wave that's following our mouse around, and it's a ripple shaped. Pretty cool, right? Okay, there was something wrong. Yeah, this works really perfectly. But what's wrong is, it is applying to the whole plane. We don't want that. In this website, it only applies to a specific area. So if I want to map it into a specific radius, what I can do is, we created a circle here, right? Previously. So I'm going to map this wave. I'm going to restrict this wave to this circle. So let's say what we have. Let's check what we have. To output this, I'm going to do the same for this V circle. Okay, I'm getting this wave and it is only limited to this specific radius. Pretty cool, but it's really slow, so I'm just going to multiply the time with like 3. 3 is too much, and I'm just going to increase the frequency. Really cool. Now what if I subtract the time? Now it starts from the, it origins from the center. If I was adding the time, it comes from the outside to the center. That's not what I want. I want the wave to originate from the center. Okay, sounds cool. But if you want to increase the size, if you want to increase the restriction of this circle, we already created circle here, right? This is the radius. So let's say float radius 0.1, and I'm just going to pass radius. radius, spelling mistake, radius. Cool. Okay, now it's really small. Sorry, it should be around 0.5 exactly. But what we have right now is exactly what is here, isn't it? Just look at that wave. It follows our mouse around. So I'm just going to output back to the image we have. Wow, that is so freaking cool. It is as simple as that to make this wave. But you see, these waves are already playing even if I'm not hovering over them. That's not cool, right? So what I can do is I can come here. I'm going to say you enter. I'm going to say you enter. I'm just multiplying it with you enter. So what's happening is, okay, now it's not playing, but if I'm hovering over this, it should be playing. Okay, I think something is wrong. Oh, GSAP target 0 is not found. Did we create a U enter? Yes, we did. I created the aspect 2 times. For some reason, I didn't see that. Okay. For some reason, this was duplicated. I didn't even notice it. So let's say, oops. And then what is the problem? Image material, uniform.
Wait. Mi gente, oigan bien. Lingang guli 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 wacha lingang bu. 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 Lingang guli 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 wacha lingang guli guli wacha. Gang guli guli wacha. Gang guli guli wacha. Gang guli guli wacha. Esta fue la primera entrada, ahora la segunda.
I'm stupid. I shouldn't have done this value. Now I know why I shouldn't trust GPT. Okay, there you have it. There you have the mouse. Okay. Now if I'm not hovering over this, I don't see the wave. As long as I start hovering over this, I can see the wave following my mouse around. Pretty cool, right? But I think the amplitude is pretty low. So if I want to increase the amplitude, maybe if you want to add a GUI or something like that, let's say amplitude, and then I also need the frequency, which is basically how much circles it should form in 1 second. Frequency, I gave it as 10 or 20. Let's say the amplitude is 20 as well. Frequency will be here. The amplitude will be here. Whoa, that looks really cool. Crazy shit, right? Well, amplitude is too much. I don't know, 15. The time is still too slow. There you have it. But 10 is perfect. Let's go. We have this crazy wave effect, and if you look, it is the exact same effect we have. And now what's left is to make the scaling and the magnet effect. So what's happening in this magnet effect? It just happens in the x direction. Okay, so if I want to move this plane in the x direction, what I can do is I can say position dot x plus equal to 2. Okay, now it moved 2 units to the right, but that's not a one. I want this to move in the x direction with my mouse. So I'm going to say uMouse.x. Let's see what we have. Holy shit. Now everything is overlapping and stuff is going on. Okay, now I'm just going to decrease the intensity. Okay, that's perfect. But this is in the opposite. If I move to the right, the plane moves to the left. If I move to the left, the plane moves to the right. So for making that, I just have to invert this by saying 1 minus, or yeah, there you have it. Now we have the magnet effect. Pretty cool, right? And you can always increase the intensity of how far it should go. Yeah, this is too much. 0.1 is perfect. Now we have everything, and what's left is to scale this thing. Okay, so how should I scale this? So I'm going to increase the size in the x and the y direction, and I want to leave the z direction as it is. So I'm just going to say position dot xy, which is equal to, let's say what we have, scale, and let's say 1. Let's see what happens. Okay, let's not do that. I think it's multiply equal to. Okay, what about 1.1? Okay, now you can see the scale increased, and that's not what we want right now. So I'm leaving at 1, which is the normal size, and I'm going to add a value which will be 0.1, which is the scale. So I'm going to say float scale, which is the amount that I want to scale when I hover. So I'm just going to add the scale here, and then it will only happen when I hover. So there you have it, but the scale is too much. Let's go. Now we have this, everything. Pretty cool, right? We have the magnet, we have the wave, we have the scaling effect. Pretty cool. Works perfect, right? It works perfectly. Now what else we need to do is, what if I can make this wave a bit more visible? Now it's not clearly visible in the fragment shader. What I mean by that is, what if I just did this equal to, I'm just going to change the RGB value, and I'm just going to add the V circle to it. Let's see what we have. Whoa. Now we can visually see the wave, as well as what in the Vertex shader we can also see the wave. But this is too much. What if I just divided it by 200 something? Now you can see the slight white color of this wave. It's much more visible than it was before. Isn't that it? Now you can always increase the intensity. This is so freaking cool. This is so freaking cool, let me tell you. But if you see, this easing of the scale is not that great. So I'm just going to change the easing here. Let's say ease, I don't know, circle. Yeah, that's fast. That's perfect. This is exactly what we need. We have the effect. It was as simple as that to create this crazy effect. I hope you guys loved it, and if you guys have any doubts or something like that, then make sure to comment on this post. Yeah, see you in the next one.